So the next parameter you are going to study is the ABCD parameters, or also called as the transmission parameters. Okay, so to write the equation for the ABCD parameters, first you need to understand the meaning of the word transmission. So transmission means transmission of energy from V1 I1 to V2 I2, or transmission of energy from the input port to the output port, or in other words, transmission parameters or ABCD parameters means it's defined as the equation for expressing the equations for V1 and I1 of the input port in terms of the V2 and I2 of the output port. So which means we are basically writing the equation for V1 and I1. This is the meaning of the word ABCD parameters, that is expressing in terms of V1 and I1. That's all. So what is V1? V1 is given by AB2 minus, okay, this is first time we are introducing a minus over here. So AB2 minus BI2. This is the equation for V1, and the equation of I1 is CB2 minus DI2. That's it. This is called as the ABCD equations. Okay, so here you need to find, here when this problem comes, you need to find the value of A, you need to find the value of B, you need to find the value of C, and you need to find the value of D. So what is the equation for A? From here itself you can write that. What is the equation of A? A is equal to V1 by V2 when I2 is equal to 0. This is the equation for A. What is the equation for B? B is equal to V1 by I2, V1 by I2 when V2 is equal to 0. Right? What is the equation for C? C is equal to, so this is actually, when you look over here, it's actually minus V1 by I2, right? It's actually minus V1 by I2. It's minus V1 by I2 because there's a minus sign over here. So what is the equation for C? C is I1 by V2 when I1 by V2 when I2 is equal to 0. Or what's the equation for D? D is equal to I1 by I2, okay, I1 by I2 when V2 is equal to 0. Minus I1 by I2, minus I1 by I2 when V2 is equal to 0. So this is how we express the equation of these functions. Okay, so here you need to find, this is how we find the value of A, B, C and D. So this is all, that's it. This is about the ABCD parametric equation. So next we are going to learn is what are the conditions of reciprocity and symmetry of a ABCD parameters. Okay, that's what you're going to learn. So how to define the condition of reciprocity. First we'll discuss about that. Okay, so condition of reciprocity, or when does a network is said to be reciprocal. A network is said to be reciprocal if the ratio of the excitation and the response is the same when the position of the excitation and the response is reversed. Okay, so first what I'm going to do is that I put the excitation in the input port and I put the response in the output port. Then what I'm going to do is that I'm going to find the equation of the ratio between excitation and response, and then what I'm going to do is that I'm going to reverse the position of the excitation and the response. That means in the second case I will put the excitation at the output port and the response at the input port, and again I will find the ratio of the excitation and excitation to response, and if both the ratio is correct, then the network is said to be reciprocal. Okay, so first I will put the excitation at the input side. I'll first put the excitation at the input side. So this is the excitation. Okay, this is the voltage. This voltage is called as Vs. So therefore V1 is equal to Vs, and this is I1. And as for the output side, I will short it. Okay, I will short it, and this current over here we know is called as I2, and this response is called as I2 dash, where I2 is equal to minus I2 dash. Okay. Also, since it is shorted, we know that V2 is equal to 0. It's shorted, right? So therefore, the potential difference is the same across this point and this point. So therefore, V2 is equal to 0. So in that case, now we need to simply find the ratio between Vs by I2 dash. That is the ratio of the excitation to response. This is what you need to find, Vs by I2 dash. So to do that, all I have to do is substitute these values over here. So what is V1? V1 is Vs. So Vs is equal to A, and V2 is 0. So this term becomes 0 minus B, and what is I2? I2 is minus I2 dash. Minus I2 dash. So therefore this is nothing but B I2 dash. Or in other words, I already found the ratio, right? That is Vs by I2 dash is equal to B. So this is the ratio to the ratio of the excitation to response in the first case. Now in the second case, what I'm going to do is I'm going to reverse the position of the excitation and the response. So the circuit will become like this. That is, the response will be over here, okay, and the excitation will be over here. So this is Vs, so which means V2 is equal to Vs, and this is I2, this is I1, and this is the response, I1 dash. Okay, so here I1 is equal to minus I1 dash, and what else do we have? Yes, and V1 is equal to 0. So what I'm going to do is that here the ratio of the excitation of the response is called as Vs by I1 dash. So which is what I'm going to find over here, Vs by I1 dash. So substitute these values over here in this equation. I'll get V1 is equal to 0, right? V1 is equal to 0. So this will become 0 is equal to A V2. V2 is Vs, so A Vs minus, and BI2 is over here, so minus BI2. Okay, this is the other part, first equation. What about the other equation? I1 is minus I1 dash, so this becomes minus I1 dash is equal to C, V2 is Vs, CVs minus, and what about I2? DI2 minus DI2. Okay, so what I'm trying to find the value of Vs by I1 dash. So here there's Vs, here there's I1 dash, but this is the term I don't want, I2. So what I'm going to do is I'm going to express I2 in terms of Vs over here. So this will become AVs is equal to BI2, or in other words, I2 is equal to A by B Vs. So substitute that over here. So this will become minus I1 dash is equal to C Vs minus D, and I2 is into A by B Vs. Okay, so I want to remove this minus sign over here. So therefore this will become I1 dash is equal to D into A by B Vs minus C Vs. Okay, and let me take Vs common. So this will become, and also I will cross multiply B and C. Take the LCM as B itself. So this will become DA minus BC by B into Vs. Or in other words, Vs by I1 dash is equal to B by AD minus BC. This is the equation for Vs by I1 dash. So this is the ratio of the excitation to the response, and this is the ratio of the excitation to the response. So a circuit or a network is said to be reciprocal if these two ratios are the same. So therefore, for the network to be reciprocal, Vs by I2 dash is equal to Vs by I1 dash. Okay, don't forget this Vs and this Vs are not the same. Okay, this Vs is this Vs over here, but this Vs represents this Vs. Okay, so don't think that you can cancel each other and say that I1 dash is equal to I2 dash. Okay, that will be stupid. So therefore this is Vs by I2 dash is equal to B, and Vs by I1 dash is equal to B by AD minus BC. So both the B will cancel each other, so you will get AD minus BC is equal to 1. So this is the condition of reciprocity, or a network is said to be reciprocal if the equation is satisfied, that is AD minus BC is equal to 1. Okay, so this is how we express the condition of reciprocity of a ABCD parameters. Next is checking the condition of the symmetry. So condition of, so when does a network is said to be symmetrical? A network is said to be symmetrical if the voltage to current ratio of one port is equal to the voltage to current ratio of the other port when the opposite ports, when in both the cases the opposite ports are open. So that means what I'm going to do is that I will find the equation or the ratio of, first I will find the ratio of V1 by I1 keeping the output port open. So this is V1, this is I1, and here V2, and here the output port is open. Open means then I2 is equal to 0, right? I2 is equal to 0. So in that case, what will be your equation for your ABCD equations? So we know that V1 is equal to, it becomes V1 is equal to AV2 minus BI2, but I2 is equal to 0, so that's it. So this term becomes 0. So it becomes V1 is equal to AV2. That's it. What about the second equation? I1 is equal to CV2 minus DI2. But here again I2 is equal to 0. So this term will become 0. So therefore this is the equation. And your job is to find the value of V1 by I1. So what is V1 by I1? Easy, right? V1 by I1 is equal to A by C. Okay, V2 and V2 will cancel each other, so it becomes A by C. So this is the first case. Then second case, what I'm going to do is that now I'm going to find the ratio of V2 by I2. Okay, I'm going to find the ratio of V2 by I2 keeping the other port, that is the input port, open. So this will become, so this will be the equation, that is this port will be open, the input port will be open, so therefore I1 is equal to 0, and here this is your network, and this is your output port as usual, and here this is voltage V2 and this is I2. Okay, so in that case, substitute the equation again. So here you have V1 is equal to, so what is the equation? V1 is equal to AV2 minus BI2 There's nothing to substitute over here, right? What about the other equation here? I1 is 0, so this will become 0 is equal to CV2 minus DI2. So what you want is, you want to find the ratio between V2 and V2 by I2. So here that equation, this equation is more than enough for that, right? So here you can find, so what is V2 by I2? From here, so you can say that V2 by I2 is equal to, let me see, beginning I2 over here, the C will go down, D will be top, so it will become D by C. So V2 by I2 is equal to D by C. This is the equation. So this is the equation, voltage to current equation of the input port keeping the output port open, and this is the voltage to current ratio of the output port when the input port is open. So when does a circuit said to be symmetrical? If both the voltage to current ratio are the same. So for the network to be symmetrical, comma, V1 by I1 is equal to V2 by I2. Okay, remember V1 by I1 means of this network's V1 by I1, and this V2 by I2 means this network's V2 by I2. Okay, they both don't belong to the same circuit, right? So what is V1 by I1 over here? A by C. And what is V2 by I2 over here? D by C. So C and C will cancel each other, and you will get A is equal to D. This is the condition of symmetrical of ABCD parameters. That is, a network is said to be symmetrical if it satisfies this equation, that is A is equal to D. So that means how to check whether this network is symmetrical or not. When you find the value of A, when you find the value of B, C and D, and when you see that the value of A is equal to value of D, then you can say that the circuit is symmetrical. Okay, and also when you find the value of A, B, C, and D, and when you find the value of AD minus BC, that is, you multiply AD and you multiply BC, and you find the difference between them, and if the value is equal to 1, then you can say that the network is reciprocal. Okay, so this is how we do for ABCD parameters.